Another type of reaction is the decomposition reaction. Decomposition is the exact opposite of a combination. Instead of putting things together, what we're going to do is we're going to take apart. So decomposition is to take apart. We're going to take a single reactant this time, so there's a single thing on the left-hand side of the equation. Single compound or one compound. Let's do this. One compound on the left-hand side of the arrow. In its simplest form, what we're going to do is we're going to take apart the compound on the left-hand side of the reaction arrow and break it into its elements, essentially. So I can see that I have magnesium and chlorine. Now, I can't just leave chlorine as Cl. Remember, chlorine is a Hankelbrief. We've got to watch for those. Hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, fluorine, when they exist or are present in their elemental form, they form diatomic molecules. So these guys are diatomic. Means two atoms. So instead of just Cl, what I'll have is Cl2. Balancing, this is already balanced. Again, in its simplest form, all I'm doing is taking things apart, taking the compound apart. So for this next one, this will break down into magnesium and sulfur. With water, that would break down into hydrogen and oxygen. Again, these two are Hankelbriefs, so they both get the twos because they would be in their elemental form, and they form diatomic or two atom molecules. This one I should probably balance. I know I need 2 over here and a 2 over here. I needed the 2 here because I only had 1 oxygen, so 2 times 1 gives me 2 to match up with the 2 that I have over here. And then I needed the 2 here because then I would have 2 times 4, 2 times 2, which would give me 4 hydrogen atoms over here, and I've got 4 hydrogen atoms over here now. Again, when we're balancing, we're counting individual atoms. Keep that in mind. There can be more complicated decomposition reactions. We'll probably stick to many of the simplest ones, but the more complicated, there are a couple of patterns that I do expect you to be able to recognize. Whenever we take a metal carbonate, that would be a metal combined with the carbonate ion, CO3 2-. What will happen is we'll form a metal oxide. Again, from before, this is a compound containing oxygen. Compound containing oxygen. So let's think about an example here, something like perhaps aluminum carbonate, Al2CO3, 3. That would break down into a metal oxide. That metal is aluminum, so it'll make aluminum oxide, which is Al2O3, and carbon dioxide. Carbon dioxide is always going to be one of the products. At this point, we probably want to balance this up. I've got 2 aluminums here, 2 aluminums over here. I've got 3 carbons, so I'd probably want to put a 3 here to get me 3 carbons. And I've got 3 times 3 gives me 9 oxygens. With this 3 out in front here, I've got 6 plus another 3, which is 9 oxygens. 6 plus 3 gives me 9 oxygens, so I'm set there. Another pattern is a metal hydroxide. Again, keep in mind this is anything or a compound containing the hydroxide ion, OH minus. Let's take something like calcium hydroxide. Whenever we break this down or decompose this, we'll get a metal oxide. So the metal oxide would be calcium oxide and water. Water will always be one of the products. We can check our balancing. 1 calcium, 2 oxygens, 1, 2 oxygens, 2 hydrogens, 2 hydrogens. So these balance. Again, this is the opposite of a combination or synthesis reaction. I'm taking things apart.